So today I just wanted to do a quick Partmaker demo, real high level overview of why I like this software for Swiss. I get a lot of questions on Instagram about, what CAM package people should use if they're getting into Swiss. And so I prefer Partmaker, and I'll just go through some of the reasons why. Now, I just want to start out by saying Partmaker is not going anywhere. I know a lot of the other brands are saying Partmaker is a dying software, Autodesk is going to kill it. That is not the case. So right now, uh, Partmaker or Autodesk is really pushing hard on their Fusion package, and I'm sure eventually they'll want to move Swiss into Fusion, but as of now, it's not capable of it. And then even if they were to somehow move a lot of the Partmaker stuff into Fusion, Fusion uses a completely different post language, and so none of the Partmaker posts would translate over. So they would have to rewrite all the posts. It would be a massive undertaking, and to be quite honest, I don't think that they will ever do that. I think Partmaker is always going to be its own standalone package. That's just my personal opinion, but I know for a fact they are not killing it anytime soon. So it is not a dying software, and they would not kill it unless they already had another solution that's proven, vetted, and that most of the industry has already accepted. So I would say even if that were to happen, we're 15, 20 years down the road from that. So just rest assured, Partmaker is not going anywhere. The other thing I like to mention about Partmaker is it's the only CAM package that was purpose built for Swiss. There's a lot of other Swiss packages out there, but most people are using their turn modules, their turn mill modules to accommodate Swiss style programming. You're using some custom settings, and not to say any of that's bad, but I'm just mentioning that Partmaker is the only package on the market that was purposely built specifically for Swiss, and then everything else was an afterthought. So all that being said, if you've never seen Partmaker, this is the interface. It does look a little different than most interfaces. And I know some people say they don't like the way this looks, but I really do. And I really like the layout, and here's why. So you can see we really have two windows here. You have the solid models down here, and you have 2D geometry up here. Now you can program everything off of a model. You can also program everything without a model using just 2D. You can draw it all. It's very simple to draw in Partmaker. But if you do have a model, what I typically do, rather than program off the model, I use the model to get my geometry up into the 2D window. So I'm a very simple-minded guy. Partmaker simplifies everything by doing this method. And so that's something that I really do like. I know there are people out there who would hate this. It's just personal preference. But for simple-minded people like me, I really like this. It also takes some complicated tool paths and just simplifies those as well. So this is a style that I really prefer. Now you'll see over here on the left, we have our little like toolpath tree. Really, they call it the Job Explorer, but I know people refer to these as trees. And you'll see right now, I don't really have all my programs in the order that it would run in the machine. So I purposely have cutoff is programmed here, and drilling is after that, and whirling is after that. You can program these features in any order that you want here, and then we can reorganize them later. And I like that as well. I'll kind of show you why. Right now, I'm going to go into our setup dialog box. So on Partmaker, this is where you would establish your like OD of your stock, the length of your part, guide bushing, all that information. But this is also where you choose each machining function. So right now you'll see I got main spindle turn as number 1. Over here in this picture, it shows kind of a turning face window. So what you would want to do to keep this as clean and organized as possible is program every main spindle turning feature under this machining function. And then, so like if we're going to do sub spindle turning, I have another machining function for turning on the sub. All we've done to change it to sub spindle is check this one box. That's it. Everything else is the same. Partmaker will flip your model around and get everything ready for the sub spindle. But you would, under this machining function, you would want to do all your sub spindle turning operations. For milling, I have a milling face window here, and I will do every milling operation I can do that is at the C angle of 0. So you really can organize all of your tool paths really cleanly just under each machining function. Now, the other thing I like about these machining functions, or what we actually call them face windows as well, is that you're not recreating new work planes. Partmaker has predefined all of these work planes by just choosing the machining function you want. So like here's another example, mill XY. Actually, let me go in here. So you have turn. Here's mill XY. The picture changes over here, and you can see mill XY would be using an end mill from the face, really milling in the X and Y axes. We wanted to do mill 5-axis plane, which we do have a 5-axis hole on here that I'll show you later. We could do that. Mill ZY would be cross milling, using like your gang style tools, doing any sort of cross milling, cross drilling. You could do like mill end polar if you still need to move a mill from the face, but you don't have a Y axis. You could do mill end polar. So we have all these options. And when you do select one of these machining functions, your work plane is going to already be automatically built, by Partmaker. So I'm going to delete this one. And I'm going to exit out of here. So let's just start with the turning. And I am going to hide all of these tool paths except for whichever one I have selected at the time. I'm going to do that by doing this. So once we're in our turning face window, we only have 2 options for tool paths that we can do. We can do a hole, or we can do a new profile group. So let me click on new profile group. The new profile group will be any other kind of turning besides a hole, really, or besides like tapping. So we can do turning, contouring, grooving, threading, a cutoff, or thread whirling. Now, for contouring, we could also be turning on the outside of the part, or the inside, or the face. Whoops, I'm going to go back to out. Okay. Now, one other thing to know, this is something I really, really, really like about Partmaker as opposed to most other CAM softwares. So all of the settings you need to accomplish this turn are in this one dialog box, with the exception of maybe your leads. You get another dialog box for your lead in and lead out. Every other software is going to have 3 to 5 tabs with all kinds of settings. And if you are doing some really complex stuff and you need to control your tools in really strange ways, then yeah, you would probably want those settings. But Partmaker has really eliminated everything except exactly what you would need for 99% of turning operations. So you can see we can right here, we could add some material to leave for the finisher here. So we would leave 5 thou on X, 5 thou on Z if we wanted to. If we want to take multiple passes, we could say, go 50 thousandths at a time. Partmaker does not have stock automation really, so you would have to add this in. You'd have to say, okay, there's 200 thousandths left. This is one feature I don't like, but not every software can be perfect with everything. Then you have face clearance on the diameter, clearance on the diameter, clearance on the face. And then you wouldn't need to do 2 operations for roughing and finishing. You just have to check this box for finishing. So you can select 2 different tools, one different tool for roughing, one different tool for finishing. You can select the same tool to rough and finish. And then if you are using 2 different tools and you want a pinch turn, all you have to do is check this box for pinch turn. So you can do obviously some complex turning in here, using pinch turning and everything, but it's all established just in the one dialog box, which I really, really, really like. If you are starting to have problems, you don't have a million settings you have to go through to figure out what is causing the problems. So let me close this, and I'm going to delete this one because I'm not going to need it. Now, once you do have your settings in here that you want, like let's say we have this turn. To chain your turn, it's really simple. All you have to do is select the chaining function and then whichever snap mode you want. So how do you want to snap to your specific points? Do you want to snap to an end of a line, to the intersection between two lines? Do you want to go to the middle of a line? Usually this one works for 90% of scenarios. So I'm just going to say we're going to turn to here. And then we'll verify that. You can verify in the 2D window, which is really quick and dirty. I like that. Or you can, and you see the toolpath on a solid, but we can also run it through the solid simulation. And I'm going to slow that down real quick. When you do that, obviously you saw the guide bushing is there. So you can see if you're going to be falling out of the guide bushing on roughing and finishing operations. And there is going to be a simulation later on where we can simulate the whole part. This is just a quick simulation for this one toolpath. So yeah, we can verify all those there. So for drilling, okay, so I mentioned before we have our new profile group for pretty much everything besides drilling. Well, let's say we need to drill or tap, we can go in here and we have our whole group parameters. Again, very few settings in here that you need to change. Just say we want to use the main operation will be a drill, spot drill, tap, rotary broach. For this case, we'll just say drill. Select whatever diameter tool you want. I'm just going to leave all these for now because I'm going to delete this operation anyway. And then say apply. Now Partmaker does have cycles. So if you wanted to have, like if you can see on my list of cycles, if you're doing the same holes every single program, same size, then, and you're using all the same tooling, then you could just select whichever cycle you want. It's already predefined. I'm creating a new one because we don't have one for the 1/4 inch diameter in here. But we could say drill, just standard drill would go all the way to depth and come out. Deep hole would peck. You also have chip break, variable step. So these types of drilling ops, but I'll just say deep hole. Now, if we wanted to spot this hole, we could just say insert operation and we'll spot it beforehand. But you want to make sure the major operation that's checked is for whatever you had established before. So we had established the major operation is going to be a drill. Now, if we wanted to spot drill it, and then tap it, let's just add a tap. And you can do float tap, rigid tap, whatever. And then, yeah, we could add other stuff, but there's no sense in that. And then we would just select our tools and we would say, okay, it's going to give me errors because I didn't select any tools. But that's how you can establish drilling op. So really quick, delete this. But you would want to do all of your turning operations. Like I said, you don't have to do them in any particular order. Just, whatever feature you want to program first, go ahead and get that done inside of your turning face window. Now, let's say I want to go to a milling face window. Oh, and I want to also mention to mill the hex, we also said we're going to mill on the subspindle. So we just had to check this box for subspindle, and that's it. And it flipped our part over as Partmaker needs. And I'm not going to really go through the orientation of models and stuff in this video. But all you need to know is really, excuse me, let me delete this. Since we're just going to try and mill a flat, I just need to select the flat on the model that I want, and then I'm just going to project that geometry up here. So I don't need geometry for this entire part up here. I could if it made me feel better, if I liked the look of it, but really I just need the geometry for this one flat. And so I've got that here. So super simple. Also, you'll notice up here now, since we're in a milling face window, we have the option for hole, just like before. New profile group for milling. This is going to be any sort of standard milling. And then we now also have the option for surfacing. So you have only 3 options. So like I said, again, they just simplify everything as much as possible. We're not going to be doing any surfacing. I'm just going to go into a new profile group for milling. Same thing. All your settings you need are in this one dialog box. We have the option to do contour mill, pocket mill, face mill, thread mill, advanced contour, advanced pocket. We can even do laser. 99% of the time, I'm using just contour mill on a Swiss. We're not taking out tons and tons of material typically. You just have an option to select where you want the tool position on the line that we're going to end up drawing. If you look at the picture over here, it kind of shows the end mill is going to run this. The center of the end mill is going to run right along the line we're going to draw. This picture is not great for this, but that's what that says. Left contour would be putting the end mill on the left side of whatever line we're going to draw, but really left is always climb cutting, and then right would be conventional cutting. So I'm going to leave it to left. Now, if we need to know the start position of this feature, I could just say extract the parameters from the solid. I click on this feature, and then these are going to change as soon as I hit extract, as you can see. So it's not giving a depth because that feature does not have a depth to it. It's not like there's not like a wall here. So if there was a wall, then it would say like, we're going to go 20,000 steep from the top of the feature, but this one doesn't have that. So this is going to be 0. So demo. Here we could add a bottom finish, a wall finish, initial stock again, if we want to take multiple steps over, and then just clearance moves. If you want to rough and finish, again, you just check the finishing box. You can add a different tool for this. If you want to rough with a quarter and then finish with a 1875, whatever you want to do, you can do that. We would choose 2 separate tools. And then for us, axial step is just a step down. And then we have our leads. So you can have a lead in, lead out. On your rough and finish, they can be different. So all of the settings you need are, again, right here. There's not 10 different tabs to click through to establish a million different settings, which, you know, like I said before, if you're doing real complex stuff, maybe you need that. But for 99% of stuff that you're going to be cutting, you don't. So I'll say it's going to ask me to select tools. I'm just going to delete this one because I already have my mill hex is already show you the settings. I'm only taking one pass, but these are the settings I've chosen. And then to create that toolpath, I'm going to draw the line I want. So I want it to go, I want the edge of the tool to be right here and follow that direction. To verify it in the 2D window like I did, it also shows up on the solids window. You can see it's going to depth, and we can verify it here in the solids window as well. So again, super simple to do everything in 2D. You could chain on the model if you wanted. You would just use these chaining functions, and you would choose this point here and then this point there. No big deal. You'll also notice I'm only doing one toolpath, but this is a hex. Well, I don't want to have to do 6 different toolpaths if I don't have to. So if I come in here, all I have to do to duplicate this is hit duplicate, say I want 5 copies at 60 degrees. And if I don't check this box right here, then it's just automatically going to tell the post to duplicate that, and we're not going to add any additional toolpaths here. Now, if I did check that box I just mentioned, it would create this face window and this toolpath 6 times. But it would just clutter up this tree. So there's no real need for that at all. So I'm not going to do it. So we've, and then let's go into 5-axis. So we can do 5-axis toolpaths. Very simple. All you're doing is creating a 5-axis face plane. And so you can do that by checking this box. And then you have an option for selecting to, you know, whatever surface you're trying to create that plane at. This is already established at that hole. And then from there, if we view normal to face plane, you see the hole's just looking right at you. And so what I would normally do is just say, We get that hole up there, and then you're going to program it just like you would any other toolpath. So we had created a drilling operation, and then you just select the hole. Why is it not wanting to select? Oh, it's probably because it's already selected. Yeah, it's because it's already selected. I already selected that hole. So that's all you have to do. All right. So now that I've gone through the different types of toolpaths you can have and kind of what the settings look like and how simple that is, I want to go into our process table. So this is where we will reorganize all of our toolpaths in the order we want to do it. So let's say I wanted to, drill this 5-axis hole after back turning. I can just drag it there. If I wanted to be, doing this hex maybe before I do all the ID work on the sub spindle, I can drag it there. So you can reorganize all your processes here. You can also double click on this and you have settings for multi-coolant, like high pressure, through spindle. This is where you adjust all your feeds and speeds. But again, not too many settings. If you want to output can cycle for turning, I don't actually. I'm going to turn that off. You can do all that in here. Now, one thing that I really like about Partmaker as opposed to other softwares is the ability for customization. So in this window, we also have this box called a user data box. So you come in here and these are all going to be custom options that are not native to Partmaker. So we can automatically turn on settings that just Partmaker was not initially built for. So like here's an example, G92 thread. In our threading, if we don't use a can cycle, it's going to automatically post a G32 thread. If we do check the box for can cycle, it's going to give us a G76. Partmaker doesn't have a third option natively. So we've added this custom box where if you check this on a thread, it's automatically going to do G92 as opposed to the other two options. So we can create all kinds of customizations in the posts for your programming style. So like if you wanted to use incremental H on somebody, this is probably for polar. On polar, if you want to use incremental H instead of regular C axis, you could do that. So all kinds of stuff that we can do that just really helps you customize your Partmaker experience to your programming style. So let me close this. From here, we can also access our tool windows. So these are tool settings for this tool. As you can see, again, one dialog box for all the settings. Now this is where we also do our synchronization of spindles and tool posts. I think this is where Partmaker shines far and above any other CAM package out there, especially if you are a new Swiss user. Now, most other packages, you have to kind of know what your, how do I say this? You have to know what your weight codes need to be and what your sync codes need to be, and you have to insert them in the correct place manually. Like you have to drag that synchronization code between your two operations. I know with Mastercam, you have to physically type in what code you want on each operation. And so it can be really cumbersome for somebody who has never programmed a Swiss before. You might not know what your sync codes are supposed to be or where they're supposed to line up. So yeah, that can be a little annoying. Even if you do know Swiss very well, it takes longer to sync things up. In Partmaker, we have our modes over here. This is unique to only Partmaker. So I would click on this button for this, for my face operation, and we're going to do everything through checkboxes. Since this is a main spindle operation we programmed, it's going to default to machining with one tool on the main spindle, and nothing is happening on the sub spindle right now. Now, what I want is for all these operations to run together. So I'm going to say, I want to be machining with one tool on the main, and I also want to be machining with one tool on the sub at the same time. And you see this picture changes to give you an idea of what's going on. Now, we're not going to do this for this particular job. But let's say you wanted to be pinch turning, you could just say machining with 2 tools on the main. If you want to be pinch turning while supporting with the sub, you just check follow support with the sub. So when you do this, Partmaker is going to automatically generate all of the sync codes, all of the weight codes, all of the modal codes that you need for this to happen. Very, very, very simple, very easy to use. This is my favorite part of Partmaker. This is why I will always suggest Partmaker, especially for new users, but for any Swiss programmers. I really think that this is what makes Partmaker shine. So anyways, so we want these to be machining at the same time. Now I'm going to, rather than go into each individual one and do this, we have this option to say modify modes for all consecutive processes with the same mode. Basically, for all my main spindle tools right now, everything down to here, I'm going to change them all at once. So I'll say, okay, changes them all. Now I have to do that for the sub spindle tools also. This was a sub spindle operation, and so it defaulted to machining with 1 tool on the sub and main spindle is idle. But I want to tell it for all the sub spindle operations, we're going to also be machining with 1 tool at the same time and modify these all. So they have all been changed. I do have to hit this synchronize button automatically. And then if we go into our time chart, you can see now all these operations are running at the same time as the main spindle operations. You also get over here to this vertical line. That will be a weight code. And then we have our cutoff. You can also see the horizontal line right here. That's going to be a weight code. Now our cutoff, we need to be supporting. So I'm going to say follow support. And I don't remember what this is supposed to be. Let me look at how long our part is. So I want to be, yeah, 1 inch. Okay, so 1 inch is right here at this edge. So yeah, we would want to grab right at 1 inch. So this is okay. And then everything is synced. One thing while we're in this time chart, you can see your main spindle cycle time, your sub spindle cycle time, total cycle time of the part. So you can use this for quoting your jobs if you decided to program it ahead of time. I haven't touched any of the feeds and speeds, so obviously that doesn't matter right now. So you got all your toolpaths done. You got everything synced up. Now let's simulate it. So we can go into our simulation. We do have full machine simulation in Partmaker. I'm going to show it to you. I will just, my personal opinion is I don't like this at all. We have the option for basic simulation. Let me show you what that is. Basic simulation is going to just run the toolpaths, just the tools on the stock. So you're not worrying about tool blocks. You're not really worrying about spindles crashing or anything like that. When I'm programming in Partmaker, I just want to know is the tool going to run into the stock? Are there going to be gouges on the part? That's all I really care about. I don't think that full machine simulation really gives you that much more of an accurate simulation as opposed to this. Also, something to know about simulation in all CAM softwares. This isn't Partmaker specifically. It's all CAM softwares. They're running the simulation off of your toolpaths that you've drawn. It's not running simulation off of your code. And obviously, ideally, the code is going to match your toolpath, but that's not always the case. You would need something like NC-Simul or Vericut that will actually simulate G code. No CAM software is going to be doing that. So yeah, I don't like full machine simulation, but let's just show it to you anyway. The other reason I don't like full machine simulation is like, let's say you're touching this tool off in your machine, like you're choking up on this tool a little more than normal. And so maybe you're going to crash, maybe you're not, maybe these are sticking out further in your machine than they are in the software. Maybe they're going to crash, maybe they're not, but this is not always reflective of exactly what you have going on in your machine anyway. So that's my spiel on full machine simulation. I would say 80% of people probably agree with me, 20% aren't. That's okay. You do have this option if you want to use it. So I'm going to just let the simulation run real quick. I have it turned down to run fairly slow. And it's going to run just the main spindle right now because we don't have a part in the sub. Actually, let me speed this up. Sorry. I'll go to 1. See, we got our whirling. It's hard to see, kind of. Got your 5-axis drill. You do some back turning and then now pick off. And now you can see they're both running at the same time. So this is your advanced or flow machine simulation. Let's stop it. Another thing I do like in here is you have the option to just show your finished part. If you already, maybe you've already gone through simulation, maybe you changed one thing and you just want to make sure the finished part looks like what you're expecting, you can just click on that. You know, it's got the colors turned on, so every color of my toolpath is shown here, which is nice because if, oh, we're not, that hex isn't there. See? So that's, oh, it's because my back turn is turning deeper than what the hex was called out at. So that's a programming error, see? But if you did have a gouge of some sort, then it would show the color of the gouge based on the toolpath that you had drawn. So you could see exactly which toolpath is causing that gouge. Okay, so I'm not going to fix the milling because it doesn't really matter at this point, or the back turn. So once your entire program's done now, it's just time to post some code. Get this thing in the machine. Go to generate NC program. This is where you could add your program numbers, bar load numbers. These are just a few extra settings. Say okay. Now we have our viewer. So what I also really like in Partmaker is it's a line function. So it's going to break up all of your weight codes using this align function. There's not a lot of weight codes until we get down here to the cutoff, but this makes it really easy to read. You can see like on our cutoff, we're going to position the main spindle. Then we're going to align the sub, make sure we're going to sync the spindle speeds right here. Then it's going to bring the sub spindle up. Then it's going to initiate the rest of the cutoff. And then we're going to go home and then we're going to finish the program. So this align function is really cool. You can't edit anything in this align or this NC viewer, but you can launch your NC program editor. I have Notepad selected as mine. Partmaker also does have a multi-channel editor, which looks identical to this, also has the align function, but allows you to edit code. I'm not really sure why they didn't just include that in this viewer, you know, but that's the question for the developers. Like I said, Partmaker is not perfect. There's some things I would like to change to, but I think it's the best Swiss package out there. But if you do have a different editor you'd like to use, you can go here, go to preferences. Let's see, you wanted to use Simco or whatever. All you have to do is select it, select your editor, go to wherever you want to, wherever it's saved on your computer and select that. I have Notepad selected, just personal preference. So you can use any sort of NC program editor that suits you and your machine. Okay, I think that's it. I don't have anything else from a high level point of view I think that I'd like to go into, but hopefully this kind of gave you an idea of how Partmaker works. You know, maybe it's something that suits your programming style more or suits your mentality a little more. Like I said, I'm very simple-minded. This simplifies everything to a point that some complex operations are just super easy to do. So yeah, let me know if you have any questions. Hopefully I'll respond. I'm not great about responding on YouTube, but I'll try and get back to anybody who's got some questions about Partmaker.